So star catalog comparison, just sort of this general topic about using star catalog comparison and comparing star catalogs. Next slide. So in general, a star catalog, as Dave Harold alluded to earlier, you're looking for what they call a 6-parameter solution. You start out using some sort of a survey. You just gather RA and DEC for stars, and then you, with a large data set of those, then you, and possibly from using historical positions from other older catalogs, you then roll that all into some outputs, which would be for each star, which would be a mean position, the position of the star at a certain point in time, proper motion, which tells you how to move forward in time, parallax, which also has to do with your timing constraints, you know how much it's going to shift as the Earth's moving around its orbit, radial velocity, that radial velocity plus the proper motion components allow you to really get an accurate position moving forward in time or backward in time from the mean epoch position. So, and then you also want to have some sort of uncertainty parameter on each, uncertainty estimate on each of these parameters, what's your accuracy on each of those parameters. And then every catalog is going to have a variety of flags and to mark issues, to give you an idea of how good a quality the fit was, because this is always done via some sort of statistical analysis of taking a bunch of input parameters and fitting them into a model that gives them all these 6 outputs. And so the flags tell you a little bit about how good the data is for this particular star, whether or not they spotted issues with double stars, things like that. So next slide. Different catalogs come to different solutions. Quite often they use a lot of the same inputs, but they still wind up with different solutions. There's a lot of reasons we're going to have different inputs. Different survey equipment, meaning different telescopes, different satellites. The resolution, the field of view can be different. The CCD attributes could be ground-based, could be satellite. Different reference frame for individual positions. If you're a lot of ground-based data, they take the image and then they have to reference it to some other catalog. When FAST is doing astrometry of asteroids, they're always taking it back to the Tycho 2 catalog as their reference frame for measuring the positions of each asteroid on there. So different catalogs, source catalogs for historical data. They all go out and look at previous catalogs in order to establish some sort of proper motion over time. And every catalog, whether it be the UCAC catalog, PPMXL, Tycho catalog, all those catalogs wind up using different, some same and some different catalogs as their historical basis for the fits. Different algorithms for how they work with the data, different algorithms for handling double star situations. There's just a lot of differences. Every catalog winds up being created differently, and with a mix of inputs it may be the same. Next catalog, or next slide. Yes. But the different catalogs are not independent. These are not independent samples. Every catalog, they'll have a lot of them will have the same inputs. PPML actually uses some of the UCAC data as an input to it, not just using some of the same source catalogs, but also using the UCAC catalog itself. So if you're trying to compare UCAC2 data to PPMXL data, you'd expect to see the same data most of the time, or very similar data, because PPMXL uses that catalog as an input. The same input catalog can be used, all right? Significant errors in one input catalog can affect multiple output catalogs. If you have one old position from the Yale catalog back in, the 40s, if that one data position that everybody used got an issue, it's got some sort of a big unexpected error, that can offset the proper motion estimates for that star in every subsequent catalog. It doesn't just necessarily affect one catalog. So although each catalog has some differences, they also have a lot of similarities. They also have a lot of dependencies on the same data. So while they're different, they're also kind of the same. Okay, next. So when comparing star catalogs, the first point is you really kind of need to know the strengths and weaknesses of every catalog that you're looking at. When you're looking at a comparison among various catalogs, you need to know what's important for each catalog. Magnitude range can be important. UCAC generally becomes less reliable once you get brighter than magnitude 8. Sometimes they'll have data on stars brighter than that, but that's kind of saturating, and they don't deal with saturation well in those every catalog has nuance, it has dependencies on which star magnitude ranges are good for it. The Hipparcos catalog starts to fade out in accuracy after you get around magnitude 9. They have some dimmer stars, but you start questioning the accuracy after that, and you're starting to reach the limits of their processing and how good it is. The URAT proper motions, they have proper motions in there, but they claim that they're not very accurate because they just took a very simple approach in the first release of that catalog. They took one position from the 2-mass catalog, they tried to match it to some star in the 2-mass catalog, and then they compute a simple proper motion forward from there. So for when I'm using URAT data, I normally I use the proper motion from UCAC4. That's a more sophisticated algorithm for doing proper motions, generally yields much better uncertainty numbers, so I combine those. If you look at the star catalog comparison from occult, you won't see that in occult because it doesn't show a mix. He just shows you the URAT data and he shows you the UCAC4 data, but he doesn't show a mix of the two, so you don't really see that in that catalog comparison. Knowing the specific attributes of each catalog, it's good to know what flags are important in each catalog, so you know when there might be a catalog that has a significant issue, and you should just say, okay, forget about that catalog. That I shouldn't even be considering that when I'm looking at the catalogs and trying to understand, how good the star position is. It always feels good when the catalogs all yield very similar position. That's a good thing, but that doesn't happen very often. Normally, you're seeing a lot of variation. Things spread everywhere. And in the occult star catalog comparison, he does show you kind of a large circle to give you an idea of the uncertainty, the formal uncertainty for each of those catalog positions. And so when you see ones that have really large uncertainty, you kind of just have to say, okay, I'm going to try to ignore that one. That one shouldn't be affecting it too much. Flags, they have various flags for indicating when they have issues with double stars and they have issues with saturation, things like that. And then the quality of the fit, the number of images. URAT will tell you how many images they use for the fit. Most of the time they've got a fair number of images, but there's sometimes when, for whatever reason, weather or something like that, they may have only taken 1 or 2 images for a star. And yes, they have data for it, but you have to realize that, okay, this data is, is a little more suspect because they only have 1 sample. Who knows, that 1 sample may have had an issue. So next slide. Comparing star catalogs, in my opinion, the idea is just to pick the best one catalog and go with that. Generally, and the formal error and the uncertainty is really key, and then you have to watch for issues. Magnitude out of range, quality fit, double star issues. Hipparcos computed proper motion by using only the data that it collected during its mission, which was a relatively short span of a few years, so they have an inherent disadvantage in the accuracy with which they can compute proper motion. So you always kind of have to keep that in mind, that there are certain times when you'll see a big difference between the proper motion that's given in the Hipparcos catalog versus the proper motion that would be calculated from, say, UCAC4 or one of the other catalogs that you had a large time span. And that's kind of a flag that there's some issue there that you have to watch out for. The number of images is important for URAT1. Next slide. Okay, so I advocate you generally avoid trying to average catalogs. There's a few situations where you might decide that 2 catalogs are really equivalent and they're both good. Maybe a star that's in the range of 8 or 9, magnitude 8 or 9, and you've got good data from UCAC4 and you have good data from Hipparcos, and they look very much identical. And those are kind of 2 very different types of surveys. So you could say, okay, I'm going to try to average those 2. And say that, okay, that's my best guess is an average between those two approaches. But in general, I would avoid averaging and I wouldn't offset from the default track just because several catalogs indicate they have an offset. They may all be have large uncertainty, and they all could be polluted by some ancient catalog that they all happen to use. Some early Yale survey catalog that threw the proper motion way off when, in fact, a more current survey had a better guess of that or a better assessment of that. And as I talk down here below, rarely if the 2 are very equal, then you might actually try to average them. Here I had URAT1 and HIP2 as an example of 2 I would average. So next slide. So I'll talk about this again. Right, so just a few more nitpicky details in comparing these. It can be some of the brighter stars. It gets tricky because you do have to sometimes include parallax. The brighter stars are close enough that parallax can be an important factor. In that situation, you might want to lean towards using Barco's position versus one of the ground-based catalogs because it's going to have a better job of handling the parallax offset. But looking forward to having GAIA to resolve that soon. Hopefully a lot of this will go away with GAIA. Next slide. GAIA. Okay, Dave's already talked about it a lot, so I don't want to repeat too much of what he's already said. The key is it's going to help us a lot with a lot of stars, but not every star, because quite a few stars out there are either double or somewhat compromised by possibly being double. So we're still going to have to wait a while before they really handle all those situations, but hopefully we'll get a lot of benefit in the short term. Hopefully a lot of our target stars will have GAIA data, and particularly since they're going to do this Tycho GAIA solution, which will help for stars all the way up to or down to about a magnitude of 11.5, and then beyond that, Dave is working on a catalog that'll add UCAC for proper motions in the other situations. So that should get us in pretty good shape for star positions, and hopefully the star catalog comparisons will, for most events, will be a non-issue in the near future. We'll just rely on GAIA. Next slide. Right, so I'll talk about a little bit. GAIA will eventually also add asteroid positions. It'll be interesting to see how that unfolds. We might get some of those early on. Short term, GAIA is going to help with asteroid astrometry because the GAIA reference frame will be very useful, very deep, very dense. So when you're taking pictures of things like the 61-inch astrometric telescope at Flagstaff and some of those things, we'll be able to get good relative astrometry, actually good GAIA-based astrometry. It should allow us to do some tweaking of the position for paths until we get better orbits. And that's what I mean here by this relative astrometry thing, doing relative-based astrometry near term. I think we may be able to get some benefit with that. Basically what the GAIA reference frame is, hopefully will be solid enough that we can treat that like a large relative reference frame.
Yeah, so a question. You don't have to do last second astrometry where you get it on the same CCD frame. You can only do that the night before or 2 nights before the event.
Right, David just,
you can do it
right.
anytime as long as you do it against the GAIA.
I'm hoping that will be true, yes. That David just asked the question about in the past. We've done a lot of these relative astrometry things. We'll take a picture maybe a few days beforehand. If the asteroid is moving slow enough that the instrument has a big enough field of view that they can get the asteroid and the star on the same frame, then you get a very accurate relative position between the two, and you can use that to fine-tune the path position. We've done that a few times in the past, but there aren't many instances where we've been able to do that. But now with GAIA reference being so accurate, I'm hoping that we'll be able to get a lot of benefit by taking pictures well ahead of time and not having to have both the star and the asteroid on the same frame, on the same image. They can just both be in the GAIA frame, and we'll be good with that sort of approach. Long term, the GAIA reference frame observation should improve the accuracy of orbit fits, but frankly, I think there's going to be a lot of work to be done in software. I think the current orbit fitting software, well, it's definitely right now is not up to dealing with GAIA, so they're going to have to evolve that a little bit. Hopefully that won't take long. And but there are people working on it, so I'm hoping that happens soon. Next slide. Oh, is that this one?
Yeah. Tap the laptop square at the top.
Hit the secret button.
Laptop.
I hit the computer. Okay. All right. Is that the last one, or we got more? Okay. Questions? Sorry, I went kind of fast.
Not specifically about that, but about UCAC particular.
Right.
Just with a handful of stars I've used from it,
Mm-hmm.
we've come up with several stars that, put it bluntly, simply
Weren't there on a like a DSS image, right?
And I don't think it's necessarily an instrument magnitude issue. I think it's just a
No, processing issue. Yeah, it could have been a, could have been an asteroid flying. Bill asked the question about false stars, non-existent stars in the UCAC4 catalog. Yes, obviously they do exist. It's always a problem with catalogs because these things, humongous numbers of stars, it has to be processed through some sort of automated algorithm, and they miss stuff, right? UCAC4, in my experience, has generally been pretty good. It's better than some of them, and worse. But given the number of stars in it, it's actually pretty good, I think. And I try to flag that by when I do my run through and we do a search for events and we use the catalog to generate that, and then out pops a star. I do still find occasionally non-existent stars in there. I usually do that by looking. I expect to see it in multiple catalogs. If I see a star in UCAC4 and it's not in UCAC2, that's a flag. I'll try to go look at the DSS image and see if there's really a star there or not, or if there's big differences in the magnitude. If I see it's supposed to be a magnitude 12 star there, and all I see is magnitude 15 stars and all the other catalogs, I start questioning it. So those definitely happen in that catalog. But yes.
I've seen these star catalog comparisons on Brad's website,
Right.
And I know in occult there's a star catalog comparison function.
Right.
It just seems to me that what you basically said is you really have to know quite a bit about the catalogs and how they're made and where they're good and where they're not so good. In other words, we should be leaving that up to you.
Well, not necessarily me. I would encourage, if you want to go, I would encourage everybody to, Roger asked the question of, with the star catalog comparison, shows a lot of this info, and then kind of what I'm saying is it's good to know what you're doing when you're going to try to use that catalog comparison in order to maybe decide where you want to set up. And
see, I would want to depend on you because you really know this stuff, whereas I would be novice.
I try to be a good guest, but I encourage everybody to challenge me whenever you can, But it's good to know about the catalogs.
One of those up on the screen.
Oh, right.
Just give us a quick idea of what the circles kind of mean.
The circles are the formal uncertainty from the star catalog.
So does this look like to you
So
reasonably good or extremely bad or something in between?
this is,
Is there agreement here?
here's the actual uncertainty numbers. The total uncertainty at the time of event, 40 milliarc seconds. For the first one, 17, 103, 52, 52. So obviously 17 sounds good for the same thing here. It's probably a URAT. Yep, URAT 1. So obviously URAT 1 has the best formal uncertainty here. But then ideally you'd also want to kind of look at the URAT 1 catalog and say,
Go back to this one.
okay.
This is meta,
Mm-hmm.
and the circles don't overlap.
Right, they're all over the place. That's a lot. That's a pretty good scatter. But then you have to ask the question, what's the scatter from? You've got some stars here, PPMXL, PPMX, 2 mass. Those are going to have really high uncertainty, generally. Like some of these ones, CMC 2 mass, and this, they don't have any uncertainty estimated at all. But some of these numbers are pretty small, actually. HIP is large because that's kind of at the magnitude limit of Hipparcos, magnitude 9.5. So the uncertainty is pretty high on the Hipparcos number. It's, what is that, 80 milliarc seconds in right ascension and 25 in declination, but it's got a lot of uncertainty in right ascension, which might mean it might be a flag for it being a potential double star. Not that much.
Where these numbers come from, you?
No, these numbers, occult will generate these. If you go into occult and bring up a plot, Sandy asked, Bob asked if where these numbers come from, where these plots come from. If you go into the program occult and plot an asteroid occultation, then one of the options is to bring up a star catalog comparison for the star in that occultation, and it brings up a dialog like this that grabs this data off of the Vizier service and plots it all out for you, so you kind of get an idea of kind of what the various star catalogs are saying. And you can click on any one of these and actually drill into the details at Vizier and see the details, which is really, I think, a good way to do it if you're really trying to dig in and trying to understand what's going on, is to go in and look at each.
Steve, there are 2 or 3 fundamental physical
established? For example, elevation, declination. Do you use the level of a puddle of water, which would be perpendicular to the gravity? Well, how do you establish?
You're asking about RA index reference frames?
Yes.
That's a big. Art is asking about RA reference frames for RA index. That's a. And magnitude. Magnitude is an interesting question, which many of us know is there's many different ways of measuring magnitude. So the best thing to do is go out the night before and see how it looks on your telescope.
You use the center of the earth. You do not use the puddle of water.
Well, and there's an accepted definition for the mean equator of the Earth at 2000.0 and the mean pole at 2000.0, and that's how you define the reference frame. But and they all try to fit it to that. Yeah. Yeah. David. Yeah.
You know, one of the main things I look for, you know, on the star catalog comparison is the PPMX and PPMXL catalog, to see how they compare with the other things, because they're a little bit more independent than the others. I mean, yeah. Oh yes, yes, yes. I know that it's not completely independent, but they have their own you know, astrometry that they've done and things. Around 2010 or so, when we started doing some of these catalog comparisons or things, I'd always especially pay attention to that, and I had quite a few observational successes by covering the PPMXL prediction as well as the standard prediction, and it did give an indication of which way the shadow was more likely to shift. I think it's less likely now because we have the UCAC4 and the URATS catalog. I think it's changed that.
Well, you brought up a point that I meant to make that I don't think I said, which is if you see these catalog comparisons, if you see several catalogs that are good and there's a lot of spread, that's a good indication you should spread out your observers. Right.
So yeah, we you know, especially in 2010, August 31st, we had this bright occultation by the asteroid Bella, and Paul Maley and I went to Bakersfield and set up a bunch of stations, and we made sure to cover the south, which was where the PPMX path was, which was a little more than a path width south of the nominal prediction, and sure enough, the PPMX was almost right on.
Although we always have to be careful because you never know if that was the asteroid or the star.
Oh yes, yeah, right.
I won't guarantee my asteroid orbits are that good either.
Right. So yeah, that's everything's going to change with GAIA.
Yeah, we hope some of it will. At least half the equation will.
Yeah, right.
Who's next?
Thank you.
Yep, sure.
Excellent, thank you.